Okay. So hello everyone. I guess sorry for the delay. Uh, there was a issue with my internet connection, so that's why I was not able to uh, join the session on time. But yeah, I guess it's working now, so I guess we can get started right away. So this week, so let me just reintroduce myself if someone is watching me for the first time, did not come to the lecture last week. So I'm Lakshya Saggi, the problem solving TA, the NPTEL problem solving TA for the discrete maths course. And I'll be taking these sessions on Mondays from 6 to 8 p.m. So yeah, so this is our second time which we are meeting. In this session, we'll be discussing problems related to the second week's contents, which were mostly related to sets and De Morgan's law and stuff. So pretty basic stuff, but nonetheless, we need to discuss the same. And there will be some cool problems along the way, hopefully. So yeah, I guess we can get started. Uh, I'll just share my screen with everyone, and uh, just a reminder, guys, if any of you has any doubts or if you have any like technical issues that you're not able to see my screen or not able to hear my voice at any point of time, or if you have any doubts in any of the questions, also just feel free to ask in the chat. I'll try to answer all of your questions to the best of my capabilities. So yeah, so let me just share my screen and we can get started with the problems. Okay. Okay. So there we have it. So I hope my screen is visible to everyone. If it is not, just let me know via chat. Otherwise, I'll just be assuming that everyone is able to see my screen. So we have something like 10 questions for today. Hopefully, we'll be able to cover all of them since set theory is a bit easier to grasp. So yeah, first question is just a very basic warm-up question. So just so that we understand what sets are. So the first question just asks the set O of odd positive integers less than or equal to 10 is. So what is the set O? Which contains all odd positive integers which are less than or equal to 10. So I think this everyone will be able to answer on their own. So I'll just let everyone know. Okay, so Ojas has anyways written this down in the chat. The answer is. So yeah, thanks Ojas for reducing my work. I'll just copy and paste your answer. So the answer is the set O is nothing but okay. This is name is also fine. So the answer is something like this. The set will be nothing but 1, 3, 5, 7, 9 because less than equal to 10. These are the five odd numbers. Yeah. So after this, okay, so I guess we can get started with the second question, which is more of a better question. So yeah. So second question says that suppose we are given the set A as 3, 3, 4, 5, 6, 6, 9. The set B is the set B is the set which contains sets as elements also. So what is a set? Set is, so maybe I should just first discuss the definition. So what is set? Set is just a collection of objects. So note that what we have written, the definition of a set is that it is just a collection of objects. And how do we define these objects here? Like what objects? Is it an integer? Is it an alphabet? Like what is it? So the beauty of sets is, so its definition is like this object can be anything. So this object can even be a set. So what this says is that, so basically a set can also contain another set as its element. Like here we have. So here what we have is in the second question that the this is again the sets are denoted using these curly braces. So this 5 comma 9 is one set. So it is one element of the set B. So 5 comma 9 is one element of the set B. And then the number 12 is also an element of B. Then this set 1 comma the set X comma Y is also an element of set B. So B contains a set. B also contains one set of set, because this 1 comma X comma Y, this X comma Y is a set, and this 1 comma X comma Y is again a set of set. And this B is again a set. So B contains a set. B is a set of sets of set. And then it also contains that set A comma B comma C as its element. Then the set C is phi. So note that C is not phi, but C contains one element, which is phi. So as we said that a set can contain a set, so phi denotes the empty set. So the set C contains one element, which is the empty set. And similarly, the set X is X comma Y contains elements X, Y, Z. And similarly, set Y contains A comma B. Okay, so I guess the description should be clear to everyone. Like, I hope everyone understands what I actually wanted to ask in this question. So the problem now asks us which of the following statements is true. So we are given 5 statements, and like there can be multiple possible correct statements also. So we'll go over them option by option. So yeah. So option A says that cardinality of set A is 7. So is this true or false? Okay. So Ojas has already written the answer in the chat that option B is correct. But maybe Ojas will go option by option so that everyone follows along. And I'm not even sure that what's the correct answer. We'll just go along all the options and see which is correct. So option A says that cardinality of the set A is 7. So what is the set A? It contains the elements 3, 3, 4, 5, 6, 6, 9. So this contains the element 3, 3, 4, 5, 6, 6, 9. Okay, another thing to note is that set is just a collection of unique objects. Okay, I think I missed my another point in the definition. So note that set is a collection of unique objects. So for example, this 1 comma 1, if I write a set which contains elements 1 comma 1, this is nothing but equal to this set, the set which contains just 1, because set should have, so maybe I should make this italic. So yeah. So all the elements should be unique. So since 1 and 1, they are same elements. So, or maybe unique, or maybe I should say distinct objects. Yeah, that they are not same. So here 1 and 1 are same. So this set is nothing but equal to the set which contains just the element. There are some sets which there are another type of set called multi-sets in which this restriction is in which we relax this restriction, that there we can have like same objects also multiple times. But let's not get into multi-sets. We are just focus on sets for now. And in sets, all objects should be unique. So the set which contains actually elements 1 comma 1 does not actually contain 2 elements, but it just contains the element 1. So here we see that in option A, although if we count the number of elements directly, we'll see that, okay, there are 1, 2, 3, 4, 5, 6, 7 elements. But note that these 7 are not distinct elements, but we need distinct elements in the set. So what are the distinct elements actually? So the distinct elements of set A are, so what are the distinct elements of set A? So they are just 3. So 3 occurs twice, so we won't count the second time. And then there's this element 4. Then there's this element 5. Then 6 occurs twice, but we'll just count it as 1 because we only count distinct elements. And then the element 9. So only these are the distinct elements. So actually, this is the set A, the unique elements of the set. So, and note that, okay, so maybe if everyone knows what the cardinality of a set means, maybe I should just define it here. Cardinality of a set. So cardinality of a set is the number of unique or distinct objects in the set. And how is it denoted? So denoted by, so this is also a symbol for cardinality, this. So if S is a set, then cardinality of S is denoted by these absolute value symbols. So basically like the absolute value of S. This is a symbolic representation, but this actually means the cardinality of S. So what this means is that there are 5 distinct elements here. So cardinality of A denoted by this is nothing but 5, and it is not 7 actually. So option A is incorrect. Okay, now we come to option B. So option B says that cardinality of the set B is 4. Okay. So when coming to option B, so note that this set 5, 9 is one element of the set B. So you don't count 5 as 1 and 9 as 2. So there are these as 2 elements, but rather they are together present as a set. Set is one of the objects present in the set B. So this is one element, then 12 is the second element, then this 1, x, y is the third element. And then this A, B, C set is the fourth element. So just remember that, so these are actually there are just 4 elements in the set B. Even though these elements can be sets, but their cardinality won't count towards the cardinality of B, because B just contains some objects. It doesn't matter what sort of objects they are. We just want to find out the number of such objects in B. So this is correct, that the cardinality of B is 4. Okay. And then comes option C. Option C says that cardinality of the set C is 0. Okay. So what should be the cardinality of set C here, guys? It contains the element 5. So is this 0 or the cardinality of set C is 1? Okay. Okay, so Ojas has typed in the chat that is 1. So correct, Ojas. So yes, so the cardinality of C is 1, as C contains one element. And what is that element? The empty set. Note that if there was a set, uh, just note that maybe I should write here. What is the empty set? So empty set. So empty set is a set which does not contain any element. And generally, how do we denote empty set? So it is generally denoted by a 5, and maybe I should just write 5. Yeah. Oh, okay. I thought this must be a well-known symbol. Never mind. I'll just say that it's denoted by the symbol. So yeah. So I'm not presenting the symbol here. Like everyone knows what phi is. Phi is this symbol. So yeah. So it is denoted by the symbol phi. And note that cardinality of phi. So what is the cardinality of an empty set? Cardinality of an empty set is 0. So if I was just given that C equals phi, then cardinality of C would have been 0. But C actually contains one element, and that element is the empty set. If there were no curly braces here, then cardinality of C would have been 0. But since there are curly braces, this means this phi is one of the elements of C. I hope this makes sense to everyone. So then comes option D, and in option D, it asks the cardinality of X is 2. So here we see that this is again incorrect, that there are 3 elements X, Y, Z. So cardinality of X is 3. So this is pretty straightforward. Okay. Then comes option E. Option E says capital Y equal to A, B. So, so capital Y contains this A and B. These A and B, let's just assume these are these sets A and B, which are given to us. So then it says that cardinality of Y is 3. So this is incorrect, as we see that there are just 2 elements here, which are the sets A and B. So yeah, this is also correct. Cardinality of Y is 2. Okay. So okay, so Ojas is Ojas is saying that he has a doubt. So what is your doubt, Ojas? So Ojas, do you have a doubt? Okay, Ojas is typing something. Yeah, you can ask the doubt. Just ask it in chat. So while Ojas is typing this out, maybe I'll just write it here that. So option A was incorrect, C was incorrect, D was correct, E was incorrect. The only correct option was B. So hence only option B is correct. Right. Okay. Okay, so Ojas is saying that cardinality of set B should be 6 because phi is also an element of B. Okay, so this is saying that the cardinality of set B, this is the set B. So set B contains the set 5, 9, the number 12, the set 1, X, Y, and the set A, B, C. So why is phi an element of the set B? Ojas? Like there is the one of the elements of the set B is this set 5, 9. The second element is the number 12. The third element is the set which contains 1 and X, Y. And the fourth element is the set A, B. So phi is not an element of B. Okay, Ojas and Nikhil are typing something in the chat. Okay, so Nikhil, there is no phi written explicitly in the set B. Okay, so Ojas, do you get it? So note that Ojas, just one thing I have to point out, that phi will be a subset of set B because an empty set is always a subset of any set. phi will always be a subset of the set B. Subset of a set is just and we take some of the objects of the original set. So if we none of the objects, then we get an empty set. So phi will be a subset of the set B. But what we are asking is for an element of the set. Phi is not an element, but rather a subset of the set B. In option C, phi is a subset as well as the set B, set C. So the thing is, phi, you have to remember that phi is a set. Phi is not an element, phi is rather a set. So it is a subset of the set B. In set C, phi is a set, but set C is essentially a set of set. So that's why cardinality of C is 1. So I hope this has this has not confused you. Actually. So maybe I'll just write it here also now. Phi is a set of every set. So note that it is a subset, not an element of every set. For it to be an element, we have to write explicitly that it's an element. But yeah, maybe just leave it as it is. Okay, so I hope this is clear to everyone. Otherwise, you can ask me in chat if it is not clear to you. So now we go to question 3. So question 3 says that let capital A be this set 3, 5, 6, 7, 8, 9. Capital B be the set 2, 4, 5, 11, 14. And capital C be the set -1, 0, 1. Then the question says that which of the following is not a disjoint set? Again, it can be multiple options there, so we'll have to try out all the options. So we have to ask which of the following is not a disjoint set. So what's a disjoint set? I'll just explain the definition here. You must have seen it in the lectures, but I'll still be. So A and B are said to be disjoint if there does not exist an element which is a member of both A and B. So in other words, what this means is that A intersection B is phi. So maybe I should denote phi like this so that you see that this is not some English, but this is another mathematical symbol. I don't know, my symbol is not coming, but yeah. So two sets are said to be disjoint if there does not exist an element which is a member of both A and B. So an element can be a member of set A, it can be of B, it cannot be of both A and B. But if it is an element which is a member of both A and B, then they are not disjoint. The sets are not disjoint. So in other words, like, it is easy to show that this just means A intersection B is phi. Okay. So now which of the following is not a disjoint set? So would anyone like to answer this? Like after the option, this is a straightforward question. Like, are A and C sets disjoint or not? Are B and C disjoint? Are C and A unit disjoint? Okay, so we'll just try making it. Okay, maybe we can answer as we go along. So we'll have to try again option by option. Since multiple options can be correct. So the set A and C. So the A and C, you can see C contains the elements minus 1, 0, 1. So neither of these three elements belong to A, right? There is no minus 1 here, there is no 0 here, and there is no 1. So A and C are disjoint. A and C are disjoint. Right? Option B. Okay, maybe I'll show you that. Move this whole question to the next page. Yeah. In option B, we have the sets B and C, so we have to answer the next disjoint. B and C is minus 1, 0, 1. Even if we is minus 1 is set B. Right? So there. Okay. So one thing, maybe we'll come to this when we're discussing option D. So option C is now the set C and the set A union B. So the question says that, so the C option says that are set C and the set A union B disjoint or not. So note that we knew from option A and B that A and C are disjoint. We also know that B and C are disjoint. So for option C, can I directly claim they are disjoint or not? Because or do I have to specifically now compute this A union B first? Do I need to explicitly compute this A union B? Like what's the value of this set? And then compare it to C? Or can I directly say that since A and C are disjoint, C are disjoint, then C and A union B will also disjoint? Okay, so Ojas and Kavindra are saying that my screen is not visible. Okay, I'll just reshare this, guys. Sorry for this. Okay, I'll just try to reconnect to the meeting. Maybe some internet issues again. So I'll reconnect to the meeting, guys. Sorry for this. Okay, so is my screen visible now, guys? Can you let me know via chat? And is my voice clear now? Okay, cool. It's visible. Thanks for informing, guys. Okay. So now, I'll just repeat this again, what I was just saying. So in option A and option B, we know that the sets A and C are disjoint and options B and C are and the sets B and C are disjoint. So now the option C asks whether the set C and the set A union B, these two sets are disjoint. So what I'm asking is, do we need to explicitly compute the value of A union B? We are only given A and B. So for checking if C and A union B are disjoint, do I need to explicitly compute whether what's the value of A union B and then compare it to C? Or can I just say it directly using some clever argument? Yes, so just is actually correct that we don't need to explicitly compute the values of A and B. So this is a very easy property to show that since A and C are disjoint, comma, B and C are disjoint. So we know that these two things are true. So what this implies is that there's a direct implication. So what this means is that maybe I should first type and then explain that the set A union B and C are also disjoint. And why is this true? Because so what do you mean by disjointness? By disjointness, we mean that they don't share any common element, right? So the set A union B only contains the elements of the set A, or any element of set A union B is either an element in set A or an element of set B, right? So, and if it is an element of set A, then also it is not present in C since A and C are disjoint. If this is a element of set B, then A, B and C are also disjoint. So then again, it is not present in the set C. So that's why if A and C are disjoint, B and C are disjoint, then A union B and C are also disjoint. I hope this makes sense to everyone. Like, I did not explicitly compute the value of A union B. I just said, directly said from these two that these will also be disjoint. Yeah. So yeah, sometimes we can reduce our work by being a bit smart about it. So now option D says whether the sets A and B are disjoint. So similar to like what I did in option C, I just used that A and C are disjoint and B and C are disjoint, and I arrived at A union B and C are disjoint. So can I say something similar here also, guys? That since A and C are disjoint and B and C are disjoint, this means that A and B are also disjoint. So I'm claiming something like this, that since A and C are disjoint and B and C are disjoint, this means that A and B are disjoint. That C is common here, so instead we can directly say that A and B are disjoint. So is this true? Yeah, like, so just saying no. So yeah, obviously, like it is not true. Like we can. So I just wanted to point this out that this sort of transitivity property does not hold in disjointness of sets. So yeah, that you can easily say see here also that A and C are disjoint, B and C are disjoint, but if you see the sets A and B, then they have a common element. The element 4, the element 5 is common to both of them. Right? So this reasoning is actually incorrect. So they are not disjoint, as 5 is present in both A and B. Okay. So I hope this makes sense. So with this, we can move on to the next question. Okay, so next question is, let the set A equal to 4, 5, 6, 7, 8, 9, 4, 5, 6, 7, and 9, and PA denote the power set of A. Then what is the cardinality of P of A? So I'll just tell you guys what do we mean by power set. So power set, I believe you must have seen the lectures also, but I'll just make you guys remember the definition. So what's a power set? So power set is nothing but a power set is the set of all possible subsets of S. So if we take so power set of S is the set of all possible. So for a set S, the power set of S is just the set of all possible subsets of S. So for example, if S is not something like 1, comma 2, so if S has these elements 1 and 2, then the power set of S will be the set of, so it will be a set. And what will the elements of the set be? So what are the all possible subsets of S? So there are subsets in which 1 will be present, 2 will be present, 1 will not be present, 2 will be present, 1. So one subset will be where both 1 and 2 are present. So this is the set S itself, right? That 1 and 2 both were present. One set will be where 1 is not present, 2 is present. So just the set 2. The other will be where 1 is present, 2 is not present. So just the set 4. And the fourth will be where no one is present. So just the empty set, which is like what we denote by 5. Right? So power set will have these 4 elements if S is equals to 1, comma 2. So one thing to note is that the cardinality of, so one thing to remember is that cardinality of power set of S is always equal to 2 to the power cardinality of S. So this is a important formula. Like you don't even need to remember this formula, that you can uh, easily see why is this the case, that the size of power set will be just 2 to the power size of original set. Like here also we see that size of S is 2. So size of power set will be 2 raised to the power 2. And we see that there are indeed 4 elements here. So why is this the case? Because if there are n elements, let's say there are n elements in the set, like there are only 2, but let's say there were n elements. Then what can we do for every element? We can either choose that element or not choose that element. And each of this choice will lead to a new distinct power set for us. So there are two choices for every element. Either we choose that element or we don't choose that element. And each of this will give us a different subset. And this will be the set of all possible subsets. So this will give us the power set. And this size is 2 to the power. So I hope this makes sense. So now the question force is that the set A is 4, 5, 6, 7, 8, 9, and PA is this. What's the cardinality of P of PA? So first we see that, so we know that the cardinality of A is 5 here because there are 5 distinct elements, right? So this means that cardinality of P of A will be equal to 2 raised to the power 5, right? And so this will be equal to 32. So, but what we want is not the cardinality of P of A, but the cardinality of P of P of A. So the power set of A. So how do we see this? Like, how do we imagine this? It's easy to imagine. Like, you can just assume that P of A is just another set, right? So P of A is another set. So now we just want to find out the cardinality of the power set of this set. And we know that cardinality of P of A is 32. So what will be the cardinality of P of P of A? Would anyone like to answer in the chat? Like, just consider that P of A is a set now. And now what we want is the size of the power set of this set. Yes, so Nitish has answered in the chat that the answer will be 2 raised to the 32. So Ojas has also written that the answer will be 2 to the power 2 to the power n. Kavindra has also written. So good job, guys. Each of you has written the correct answer. So yeah. So considering this P of A as the set, the P of A will be just 2 raised to power 2. So power set of A, the cardinality for this will be nothing but 2 raised to the power 2. I'll not calculate like what this value comes out to be, since this is not useful to us and just the if concept was useful. So yeah. So this is the correct answer. I'll just maybe hold this answer to see that this is the correct answer. So I hope this is clear to everyone. Now we can maybe move on to the fifth question then. Okay, so fifth question is let the set A is equals to, how are we defining the set A? So it is the element X such that it is the set of all elements X such that X belongs to Z. So note that Z denotes the set of integers. So this is a very common notation that this notation. And this notation is actually very common. So Z denotes the set of integers. And similarly, there are a bunch of other notations also, like N denotes the set of natural numbers. So these you will encounter fairly regularly, these sorts of definition. Similarly, we have Z. Similarly, there is this notation Z plus, which denotes the set of non-negative integers. So what do you mean by non-negative integers? So Z denotes the set of integers, N denotes the set of natural numbers. So note that 0 is not a natural number, right? And but 0 is a non-negative integer. So this Z plus is nothing but the set of natural numbers plus the number 0. So of the non-negative integers. So these are some notations which we'll encounter fairly regularly. Similarly, there's another notation R, which just means the set of the real numbers. So yeah, stuff like this. Just pointing it out, not so important, but yeah, it's good to know these notations. So now again, coming back to the question. So question says that I hope everyone knows what this means. Like this is defining a set, and how is this defining a set? Like this must have been discussed in the lecture. Like this notation means that we are defining a set which contains all the elements x, such that x is an integer and x lies between -2 to 5. So essentially, this set contains all the integers which lie between -2 and 5, with both included. So what will be the integers? So what will be this set A? Would anyone like to answer? Like from this notation, how do we define the set A? So we'll just typing in the chat. So we just said that -2, -1. So yeah. So yeah. So thanks. So just you have written the correct thing. So I'll just copy and paste what Ojas has written. Thanks for making my work easier, Ojas. So maybe we should just have like this in sorted. So A is just the set of integers lying between -2 and 5. So these will be -2, -1, 0, 1, 2, 3, 4, 5. So Nitish has written the integers -2, -1, 0, and 4. But note that Nitish, there are much more numbers present in the set A. Maybe you have written the answer for A minus B, but we'll come to that in a second. So similarly, B. So note that B is a set which we can't just write. Like we can't write its description. A just had this many elements, but B is the set B is denoted by X. So basically all elements which are natural numbers and prime numbers. So basically B is just the set of all prime numbers. So we can't explicitly write all the elements of B. So the prime numbers are 2, 3, 5, 7, 9, but there are infinite primes, right? So this list will just go on. So, but note that we have to identify what is the set A minus B, right? And it's not too hard to describe the set A minus B, because in set difference, what we want is just remove the elements of A from the set A, which are common with B also. So note that the A and B, the only elements common in A and B are. So if I have to find out A intersection B, it is nothing but 2, 3, and 5. And afterwards, B has the necessary matter 7, but there is no element 7 or greater here. So just these three elements, 2, 3, and 5 are present in the set B. Right? And how do we define this operation, the set difference operation? It is defined as A minus A intersection. So this is a general definition that the set difference is defined as basically we take first the common intersections of the two sets and we subtract that actually. We can't subtract the other elements because these are anyways not present in the set A. So From A we remove the elements of A intersection B. So from A we remove these elements 2, 3, and 5. So I think Nitish had already written the answer. Thanks, Nitish. So I just copy and paste this answer. So the remaining elements will be nothing but this, because we have to remove. Okay, I think one will also be there because yeah. So one is not a prime. So first of all, like remember this guys. So prime start from 2, 3, 5. So only we remove 2, 3, and 5. So what remains is -2, -1, 0, 1, and then 4. This is the answer for us. I'll just underline this. So yeah. So what's this option corresponding to? So -2, -1, 0, 1, 4. So option C. Hence, option C is correct. Yeah. Okay, then. Maybe we can move on to the sixth question now. I hope this is clear to everyone. So the next question says that in a group of 120 people, okay, maybe I should first move the question to the next page. Yeah. In a group of 120 people, 50 people love to eat dairy milk, 70 people love to eat Kit Kat, and 20 people do not like any of these. And now we have to find out how many love to eat both type of chocolates. So this may seem like a normal question, like just a word problem, but we'll convert it to a problem related to problem of set theory itself. And how do we do this? So uh, let's set A. So we denote the people who love to eat dairy milk chocolate, who love to eat Kit Kat and stuff by different sets, and we'll just try to apply the set formulas. Like you must have seen them in the lectures, like the value, like how do we find out the cardinality of A union B and stuff. So we'll just apply those formulas to find out the answer for this. So I guess this will be a bit more clear when I discuss the solution. So mhm. Okay, so now what do we do this? So we just assume, let's say the set A is the set of people who love to eat dairy milk chocolate. Set of people who love dairy milk, right? And similarly, B is, maybe I should just write A. Yeah. And then B is just the set of people who love Kit Kat. So note that they they would not be disjoint, like someone can love both dairy milk as well as Kit Kat. Well, generally everyone loves both dairy milks and Kit Kats, but and let's just denote the set U as the universal set. When we said universal set, we just mean the set of all people. So yeah. Okay. So what does the set A intersection B denote then? So if we have these three definitions, so what will the set A intersection B denote? Right. Is this also, so does this set A intersection B also denote some kind of people? Like A was a set of people who love dairy milk, B was a set of people who love Kit Kat. So this set will actually be I just repeat set of people. So if someone loves dairy milk as well as Kit Kat, so basically um, the only in A intersection B, the people will be the people who are in A as well as B. So they are in A as well as B, so they love dairy milk as well as Kit Kat. Who love both dairy milk and Kit Kat. Right? And similarly, yeah, maybe you should just leave it at that. And now what do we want? So uh, we are also given some cardinalities, and maybe we'll make use of these. So yeah. So we are given people who love to eat dairy milk, who love to eat Kit Kat, and we need to find out how many people love to eat both types of chocolate. So we need to find out cardinality of A intersection B. We also are given that 20 people do not like any type of chocolate. So these will be like the weird people for us. But anyways, we'll have to write like what does this mean? So 20 people do not like any type of chocolate. So what does this mean? Like if set A was the set of people who love dairy milk, so set A complement, I'll denote this as A complement, will be the set of people who do not love dairy milk, right? And if I intersect this with the set of people who do not love Kit Kat, then this denotes the set of people who do not like any type of chocolate. Set of people who do not like any type of chocolate. Right. So we'll just see like why do we even need this, the cardinality of this set. So first of all, like what do we need to find out? We need to find out the cardinality of A intersection B, right? We need to. So maybe I should first write down what are we given. So we are given that cardinality of U, the set of all people, is 120, right? And we are also given that cardinality of A, people who love to eat dairy milk, is 50. People who love to eat Kit Kat is 70. And people who do not like any type of chocolate is nothing but 20, right? So note that what we need to find out is, so we have converted this, the original problem into a set problem, right? Now we can just forget about these dairy milks and Kit Kats. We can just assume these as sets. We are given these sets sizes and we need to find out the size of this. So this is the problem which we want to solve. So any ideas? How do we do this, guys? Okay, maybe you can think about it yourself also. I'll also, okay, how much questions do we? Okay, so we don't have too many difficult questions after this. So maybe I'll give you guys like 5 minutes so that you can think about it yourselves and try to answer this. So I'll mute myself for 5 minutes, guys, and you can try to. So you can just ignore this whole question now, and I converted this problem to a set problem for you guys. Right now, I hand it over to you. Like, how will you approach this problem now? Just think about it for 4 5 minutes, guys, and if you arrive at the, if you think your solution is correct, do try to type it in chat so that you can share it with everyone. And yeah, so I'll mute myself for like 4 5 minutes, guys, and you should try this yourselves. Okay, so yeah, guys. Actually, I had muted myself. Like I told you guys, like I'll be muting myself for 4 5 minutes so that you can try. So by mistake, I scrolled up the chat and I was not able to see your answers. So sorry for that. So Ojas has written actually the answer. So Ojas has said that. So Ojas is writing that the answer is uh okay. So 100 people love chocolates. 70 people love Kit Kat, 50 people love Dairy Milk. Total number of people who love chocolates is 120, but the limit is 100 people. Therefore, 120 minus 100 is people who love both Dairy Milk and Kit Kat. Okay, so just is saying that there are 70 people who love Kit Kat, 50 people who love Dairy Milk, and total number of people who love chocolates is 120. So note that, that there are 100 people. Okay, so we're just saying that, yeah, so Ojas's reasoning is correct actually, but I'll just write it down in a more formal set notations. But so Ojas is saying that there are 120 people. I'll just explain it to you guys. Like this is also okay. So there are total 120 people, and 20 people out of these do not like any type of chocolate. So the remaining 100 people out of these 120 minus 20, the remaining 100 people like some sort of chocolate, right? They like either Dairy Milk or Kit Kat or both. So there are 100 people who love Dairy Milk or Kit Kat or both. And there are 50 who love Dairy Milk, who love 70 who love Kit Kat. So their sum is 120. 70 plus 50 is 120. But there were only 100 people who love chocolates. So this remaining 20, where this extra 20 come from? This extra 20 comes from the people who love both Dairy Milk and chocolate. So maybe I should write it down a bit more formally. So when we have these sets and we want to find out the intersection B, so there is one very important set formula, like which you guys should know. So I think this formula everyone also knows that the cardinality of set A intersection B plus cardinality of set A union B is actually equal to the sum of individual cardinalities of these sets. So cardinality of A plus cardinality of B is nothing but cardinality of A intersection B plus cardinality of A union B. Something like this. Okay. So if this is true, then if this formula is true, then if we want to find out cardinality of A intersection B in the problem, then it is just cardinality of A plus cardinality of B minus cardinality of A union B. Right? So here cardinality of A intersection B is nothing but cardinality of A plus cardinality of B minus cardinality of A union B. And I'll just tell you guys about the how this actually how these formulas actually correspond to what Ojas has said already. And now what we want, so we know the value of cardinality of A, we know cardinality of B, but we don't know directly. We are not given this cardinality of A union B, right? So we need to find out this value. And note that by De Morgan's formula, although we don't know this value, I'm claiming that we know its complement's value. So uh, I hope everyone knows what De Morgan's formula is. So what I can claim is the cardinality of A union B is nothing but uh, the cardinality of A union B complement. So I hope this statement makes sense to everyone. Uh, that I just replace this cardinality of A union B by this. So does this make sense, children? What am I doing here? that we know that let's just take A union B as a set S. So I'll just write it here that for a set S in a universe U, the universe is a set of all elements, then the cardinality of the set S, the cardinality of the set S complement is actually equal to cardinality of the set, the universe set minus the cardinality of the original set. So I hope this formula is like I hope this formula is like not too troubling for everyone, that we are just saying that the cardinality of complement is nothing but whatever is left instead of the original set S, right? So this is the formula which I'm using in this problem, where I just use like if we instead put S as the set A union B, if I just put it as A union B, then what I have written is like the cardinality of the set A union B is equal to cardinality of the set U minus the A union B's complement. So I hope this makes sense to everyone. And now by De Morgan's laws, okay, maybe I should mention what are De Morgan's laws also, but I hope everyone knows this also. So this will be, so this is just the cardinality of U. We are also given this. And A union B complement just becomes this. A complement intersection B complement. So this just becomes equal to this, and voila. We now we know actually all these values, so we can just plug them in. And cardinality of A is 50, cardinality of B is 70. Then from this we subtract the cardinality of U, which was 120, minus cardinality of A complement intersection B complement, which was 20. So this gives us 50 plus 70 plus 120 minus 20, which is 100. So this gives us 20, which is the correct answer. So yeah. Okay, so maybe I should just mention this as this is what we call De Morgan's law, that A union B complement is equal to A complement intersection B complement. You must have seen this in lectures, but I'll still just mention this. De Morgan's laws. And what are the laws? So first law is that A union B whole complement is nothing but A complement intersection B complement. So actually just this complement, if this goes inside, then this A becomes A complement, B becomes B complement, and all the unions change to intersections. And the opposite is also true, that all the intersections also change to unions. So the other De Morgan's law is A intersection B. So maybe I should just copy and paste this with just intersections and unions reverse. Now this makes sense. Yes. So the first law states that A union B's complement is equal to A complement intersection B complement. Second law is A intersection B whole complement is just A complement union B complement. Okay, so these are the De Morgan's laws, and this is what I use. I change this A union B whole complement to A complement intersection B complement. This, yeah. Okay, so you guys might be thinking this formula is complicated, or how do I think of this? But it's not really that difficult. Like if you just see this formula, this is exactly what Ojas also told us. So what Ojas told us was, so he calculated the number of people who love chocolate, right? Ojas said that 120 minus 20 is 100, and 100 people love chocolate. So what Ojas did was this calculation. So Ojas said that there are total 120 people, and this A complement intersection B complement denoted set of people who did not like any chocolate. So Ojas just said that out of 120 people, 20 people do not like any chocolate. So there are 100 people who like chocolate. So and A union B actually denotes those people who like chocolate, right? Because A union B denotes people who love dairy milk or Kit Kat. So we just calculated this value A union B by logic and like arrived at the value 100, that 100 people love chocolate. And then we just said that there are 750 who love dairy milk, 70 who love Kit Kat, and 100 total love chocolate. So this 20 factor extra comes from here. And it was just this formula that there were 50 who loved dairy milk and 70 who loved Kit Kat. So total 120 people, but there were only a total of 100 people in this A union B. So these 20 people were because of this A intersection B, which we found from this form, which is 20. So exactly what Oja said, but just in a more mathematical form. Right? So I've underlined this answer that this is the correct answer. Right. Okay, then if there are no doubts, we can move on to the next question. So this question says that simplify A union B intersection A union B intersection A union B. Okay. So what will be the simplest form for this? Would anyone like to answer it? Okay. So we have two different answers. So Ojas is saying that the answer should be empty set, and Nitish is saying that the answer should be A union B. Ojas is typing again something in the chat. So actually, note here that guys, like this is not a difficult question at all. It was just a question to make you guys scratch your head. Is like, why am I even asking this? So this is just a straightforward question that we are just doing like A union B. Any set intersection with itself is that set itself. So like for a set for a set X, X in I'm not writing this down because this is like I think somewhat trivial. That X intersection X is also equal to X, and X union X is also equal to X. So if you consider this A union B as a set X, then this is just X intersection X, which will be nothing but X intersection X will be X, and then it will again like it's again intersection with X will be X. So this will leave us with A union B. So I hope everyone is clear that this A union, so you don't need to actually simplify, like open up these parentheses and whatnot, like use this. You don't need to use distributive laws or something because they won't get you anywhere. So just like consider X equals to A union B. Then we need to simplify, or maybe the given expression becomes. So note that X is also a set because it is just union of two sets. And so the given expression becomes nothing but yeah. I replace A union B by X. So this just becomes X union X intersection X, which will be like you can take intersections in any order. Like it does not matter since the intersection is associative. So this will just become equal to X. And what is actually X? So X is nothing but what it was originally said A union. Okay, A union. Right. So this is the final answer for us. So maybe I should underline this. Underline this. Okay, maybe I mean. Okay. I guess. It should be some. Okay, let's leave it at that. I won't underline the answer. I'm not so sure how to underline. Okay, but this is the final answer for us. The A union B. I hope it's clear enough. That's right. It's A union B. So note that if this was MCQ based question, someone might have just confused you and would not have written actually the option as A union B, but rather something as like the complement of A complement intersection B complement or some complicated expression using De Morgan's laws or anything. So just be careful of that, that in options, one might not necessarily always give you A union B, but can give a more complicated expression. So Samrita is asking that does this also follow for union? So I leave that up to you to think about. Like I said that X intersection X becomes X. So will X union X also become equal to X? Just think from the basic definitions of unions, and I believe it will be clear to you, Samrita. Like if two sets are equal, will their union be also equal to that set itself? Yeah. Then we come to the eighth question. So eighth question says, suppose set A is equals to 1, 2, 3, 4. So it contains four elements, 1, comma 2, comma 3, comma 4. So how many subsets of two distinct elements are possible? Okay, so this is somewhat more similar to the permutations and combinations which we did last time. So how many possible subsets of two distinct elements are possible if we are given four elements in the set A? Okay, so we're just saying that the answer should be four, that answer should be six, which is 4C2. So yeah, Ojas is correct actually. So how many subsets of two distinct elements are possible? So here we can just see that we are given a set of four elements and we need to select any two out of these. Any two distinct elements out of these we need to select, and that will give us one subset. And we need to find all such subsets. So what we want is a. So first of all, we notice that cardinality of A is 4. So we need to choose all possible combinations of two elements from the four elements of it. Right? Hence, answer is equals to. So answer will be nothing but, so there are four elements and we need to choose two out of those. So the answer will be nothing but 4 choose 2. So I'll just write it down also that the answer is. So the answer is nothing but 4C2. And this is equal to just 4 into 4 minus 1 by 2, which is 6. So you can see this yourself. So just remember that, just note that here we use 4C2 and not 4P2. And this is because we just need to find out subsets. And for subset, we just need to choose the elements. The permutations are not important in a set. Just the elements are important. How do we order them is not important. So just be careful, guys, that since we are just choosing, we just need combinations. We are not ordering the elements of the set at all. If we need to order, then we'll also need computation. Okay, then. So then after the 8th question, I guess we can the 9th. The 9th question says that again it's a simplification based question that simplify A intersection B complement union B. So maybe we can try it out. So I should try to write an equation. It's not too difficult. Maybe I'll just start it and you guys can also try it along with me. So again, we'll be using De Morgan's laws here. So it will be A union B complement and then the complement there. We have it well. So this will be nothing but, so first of all, what can we do? We first of all simplify this expression using De Morgan's law. So A intersection B complements whole complement will be, so we take the complement of each of these terms and this intersection becomes a union. So this will become, so the initial A will become something like A complement. Uh, it will become A complement and then this intersection will become a union. So this will become a union and this B complement will become B itself. So this will become B itself. And this complement we had already like resolved. So this whole expression will simplify to this expression. And now we need to take its union with B. So we just write union with B. And note that the union is distributive that like A okay, so this just becomes like something like we don't even need distributive properties or anything. This we here we can just write like A complement union B and complemented with whole B. And since distribution is associative, like the unions are associative, so we can just write this as something like B. So note that since all of these are unions, this is an like union is an associative operation. I don't want to define associativity. You must have read it in high school. But what I mean is the ordering is not important. Like if I calculate this A complement union B first or this part first, I'll get the same answer. Note that if it was A complement intersection B and then this was a union with B, then I could not have done something like remove these braces. Then the order matters. Like whether we are taking intersection first or complement first or union first. But if all of these are unions or if all of these are intersections, then we can remove these parentheses and perform the operations in any order we want. So here now this B union B, if I perform it first, then B union B will just give me B. Like because X union X is also X. So this will just be equal to like something like A complement union B. So I hope this is clear to everyone. That we get something like A complement. Yeah. So Nitish, it is not A union B, but it will be like A complement union B. So I hope it is clear to you. So maybe I should underline. I don't know why it's underlining. Okay, it does underline. I don't know what's happening. Okay, I was able to underline finally. This is the final answer. So hence option C is correct. Or option D is correct actually. Sorry. It's correct. Yeah. So again, like just remember, guys, one thing to point out that this from this to this step, it was only possible because both of these were unions. But if one of these was intersection, other was union, then you could not have done this. Like if it was A complement intersection B union with B, then you need to first solve this only. Then you can't do A complement intersection B union with B. Okay, so I hope this is clear to everyone that then you will need distributive properties. Okay. Now we move on to the last question for the day, and this is somewhat of a challenging question. I hope you guys will enjoy this one. So, yeah, one of the more challenging questions of today. So, we need to prove or disprove that given any 17 natural numbers, so we need to prove either prove or disprove this statement that given 17 natural numbers, it is always possible to choose 5 numbers whose num is whose sum is divisible by 5. So we are given any 17 natural numbers. We don't have control over these 17 numbers. But given any 17 such numbers, can we always choose 5 of them such that their sum becomes divisible by 5? Okay. So this question, I believe, involves a bit of number theory also, but I think this much you guys can handle. So first of all, uh, is it true or false? Like, what do you guys think? Should we be proving this or should we be disproving this? Note that to prove this, we need to show that for all for any 17 natural numbers, we can choose 5. And if we want to disprove, we just want to give one instance of 17 numbers where we can't find any 5 numbers such that their sum is divisible by 5. Okay, so Shri is saying that this is true, and Ojas is saying that this is not true. So, any intuitions behind your claims, Shri and Ojas? Okay, so Vastav is also saying that this is true. So, Ojas is typing, I think, what's the intuition behind this? So actually, this statement is true, but I'm just curious, like, what is your reasoning for saying that this is not true? Also, or just because, like, okay, knowing the correct answer is important, but I think it is equally important to understand why is an answer incorrect also. That's why I'm just curious, like, why does we just think that this statement is not true? Okay, so we're just typing in sense. Okay, so just is saying as an example that given a set from 1 to 17, 1 plus 2 plus 3 plus 4 plus 6 is not a multiple of 5. So, or just uh, this the question is actually saying that given any 17 numbers, it is possible to choose 5 whose sum is divisible by 5. So the choosing is arbitrary. Like what this claim means is that we can always numbers whose sum will be divisible by 5. And it's not that these 5 numbers will also be given to us. The question is that the problem is claiming that the onus is on to us, that we have to choose 5. So can we always choose 5 numbers out of given 17 numbers? So here you have claimed that 1 plus 2 plus 3 plus 4 plus 6 is not a multiple of 5, but 1 plus 2 plus 3 plus 4 plus 5 is actually a multiple of 5, right? 5 plus 4, 9, 9 plus 3, 12, 12 plus 2, 1, 14, and 14 plus 1, 15. So 15 is a multiple of 5 if we choose just numbers 1, 2, 3, 4, 5. So for this set 1 to 17, we know that 1, 2, 3, 4, 5 will actually give me the correct answer. Okay. So I hope at least the question is clear to everyone. So now actually the answer is true, that this claim is true. And how will we prove this? So this is a bit more difficult. This is a bit on the difficult side. So please try to follow along guys in the following manner. Okay. Hmm. Okay, I'm just thinking, is there some cool way in which I can make you guys understand this? Or do I have to do it routinely? Let me just think about it for a minute, guys. I thought of one way, but I think there might be another trick by which the solution might be a bit more easier. Uh, okay, I think we should uh, probably do it in the manner which I earlier thought only. So, so we are given any 17 natural numbers, right? So what we do is divide these 17 numbers into 5. So let's say the 17 numbers is just uh, let's assume S equals the set of 70, the given set of 70 natural numbers. So this set S is given to us, right? So this set S is actually given to us, the 70 natural numbers. Now what we will do is divide the set S into 5 disjoint sets. So I'll divide it into 5 sets, which I'll call S0, S1, S2, S3, S4, and S. Okay, maybe not this. We'll just do it by because we're dividing into 5 disjoint sets. So these will be S0, S1, S2, S3, S4. And what will these denote? Where Si is the set of elements of S which leave a remainder of I when divided by 5. So what do I mean by this? That there are 5. So note that whenever we divide a number by 5, there are only 5 possible remainders, right? If a number is divided by 5, the remainder can be 0, 1, 2, 3, or 4. Like this is like pretty high school math stuff, that always remainder lies between 0 to divisor minus 1. divisor is 5, so remainder will be between 0 to 4. So remainder can either be 0 for any natural number, it can be 1, it can be 2, it can be 3, or it can be 4. So what I'm claiming is in this 17 natural numbers, we take the first number. If it is divisible by 5, we put it in 0, S0. If it leaves the remainder of 1, if we put it in S1, S2, S3, S4, so on, and so on. So like, for example, if the set was originally given to us as 1, 2, 3, 4 till 17, for example, if S is equals to 1, 2, 3 till 17, then what will be the set S naught? So S naught will be just the set, the numbers out of these 17 numbers which are divisible by 5. So these will be just these three numbers, 5, 10, and 15. Similarly, S1 will be, maybe I should just copy paste this. So S1 will be the numbers which leave a remainder of 1. So what will be these numbers? So 1 leaves a remainder of 1, then 6 leaves a remainder of 1, then 11, and then 16. And now we move on to S2. S2 will be nothing but 2, 7, 12, and 17. So I hope this is clear to everyone, like what I'm trying to do, and so on. So I just gave an example, and similarly for S3 and S2, right? So this is just an example so that we understand what does this S0, S1, S2 actually mean, S3, S4. So note that S can be any arbitrary set. It need not be this set actually 1 to 17, but any arbitrary set. But we can just divide it into these 5 disjoint sets, right? Note that these sets will be disjoint because a number can always either leave a remainder of 2 or 1. Like it cannot be present in both of these. So it cannot be, it will always be present in one of these sets. So now what do we do? So after doing this, okay. So the case one, so we'll do it case by case. So suppose this set S naught, this set S naught, let's suppose has a, okay. So case one is there exists an I such that Si, okay, the cardinality of Si is greater than or equal to 5. So what do I mean? So there exists an I such that cardinality of Si is greater than or equal to 5, that one of these 5 sets has a size of greater than or equal to 5. Let's assume this is the case, that one of these 5 sets has at least 5 elements, right? Then what we can actually do is, so suppose we have 5 numbers which leave a remainder of 2 when divided by 5. Suppose S2 has 5 elements. And these 5 elements leave a remainder of 2 when divided by 5. So what can I say about their sum? The sum of those 5 numbers. So what I claim is select any, in this case, if there exists an I such that Si is greater than or equal to 5, select any 5 numbers from Si. Their sum is will be divisible by 5. Do you see why will this be the case? So suppose there is, so if we select any 5 numbers from Si, So like there are 5 distinct numbers, all of which leave a remainder of I when divided by 5. So when we sum these 5 numbers, so the remainders also add up, right? So this is pretty basic number theory that if uh, if let's say uh, if there are like k numbers which leave the same remainder r when divided by a number k, then the sum of these numbers will be divisible by k. So like you can check this also that if let's say there are 5 numbers which leave a remainder of 2 when divided by 5, so that let's say the numbers are 1, 6, 11. So you can check this also. So for example, I'm just doing this in the rough. So 1, 6, 11, 16, 21. Let's say these are the 5 numbers, all of which leave a remainder of 1 when divided by 5. So you can easily observe that their sum will be divisible by 5. 6 plus 1 is 7, 11 plus 7 is 18, 18 plus 16, 34, 34 plus 21, 55. So in this case, actually, we can select any 5 numbers from SI. And so we will obtain 5 numbers whose sum will be divisible by 5. So in this case, when there exists an I such that SI is greater than or equal to 5, uh, we will be done. So we are done. So I hope this case is clear to everyone. Maybe if it is not clear, you can think about it offline also, like why will this be the case? But yeah, it's not too difficult to see. So the case 2, so there will be a case that there exists an I such that SI is greater than or equal to 5. So the case 2 will be when, so the other case will be when there does not exist any such SI. So, what does case 2 say? So case 2 will be that SI is less than or equal to 4 for all I, right? Because if SI was 5 for any one of the I's, then we have already solved that. So now what we have is SI is less than or equal to 4 for all of these I's. So for all of these, S0, S1, S2, S3, S4, what we have is SI is less than or equal to 4. Okay, maybe I should give this as like 20 natural numbers. 21, not just 17. The answer would have been same for 17 also, but it involved more arguments. So let's just say the problem was given any 21 natural numbers. It is possible to choose 5. The given set of 21 natural numbers. Till 21, then this becomes like 20. This becomes 21. This becomes 7. Yeah. Okay, so you so now do you see so what I now claim is that this case cannot happen. That SI is less than or equal to 4 for all I. Does anyone see why? Like what I claim is this case can never occur. Would anyone like to guess why is this the case? That SI can't be less than or equal to 4 for all I. Okay, so this is because see, there are only 5 possible I's, right? S0, S1, S2, S3, and S4. And we have 21 natural numbers. So if all of these sizes are less than or equal to 4, S0 has size less than 4, equal to 4, S1 has size less than or equal to 4, S2 has size less than or equal to 4, S3 or 4 less than or equal to 4, and S4 less than or equal to 4, then these 5 together can only have maximum size of 20, right? These 5 together will have a size of 20. Because these are 5 such sets, and all of these we are claiming that have sizes less than or equal to 4. But this is not possible because we are originally given 21 numbers. Since we are given 21 numbers, all of these cannot have at max 4 elements. So this is because if Si, this is a bit involving question, guys, but yeah, I think this is an interesting question. For all I, then the cardinality of, or maybe just the cardinality of S0 plus cardinality of S1. Maybe I should just copy and paste. Okay. So cardinality of S4, cardinality of S3, cardinality of S2 plus cardinality of S1. So this will be like less than equal to 20, right? Because each of these terms we are saying is less than equal to 4. But what we have is actually we originally have 21 numbers. So we had to distribute these 21 numbers. If we are distributing 21 numbers, how can the number of elements be just 20, right? But originally S had 21 numbers. Hence, we arrive at a contradiction. In this case. So that's why, since we arrived at a contradiction, this case 2 cannot occur. So always case 1 will occur, that there will always exist an I such that Si is greater than or equal to 5. And since this occurs, we can select any 5 numbers from Si, and their sum will be divisible by 5. So we are done. So hence, okay, I think this last question was a bit involving. Uh, uh, but trust me, like if you go over it by yourselves like 2 or 3 times, then you'll see that this is quite a natural question. So yeah, just I'll advise you guys to this type of question won't be asked in the quizzes, obviously, but it's good for your understanding these types of questions. So I'll encourage you guys to look at this later also. I'll be uploading obviously the PDF and stuff, so you can look at it anytime if you want. Okay, so I guess this finishes the problem for today. So any doubts, guys? We are over time, but I guess since we started late, we can have like 2, 3 doubts for like 5 minutes, maybe. So if there are any doubts, maybe you can ask in chat, or otherwise I'll be just be assuming that no one has any doubts and we'll be closing the session in that case. So we discussed 10 questions today. So yeah. Okay, Nitish is typing something. So Nitish is asking, can zero be is zero included in set of natural number? So no, Nitish, and natural numbers by definition do not contain zero. So natural numbers are just like 1, 2, 3, 4, and so on. So yeah, no, zero is not included in the set of natural numbers. So yeah, just a reminder. Okay, cool. Zero is included in whole numbers, obviously. So whole numbers are, by what are whole numbers? Whole numbers are zero and union the set of natural numbers. So 0, 1, 2, 3, 4, 5, and so on is the set of whole numbers. But yeah. Okay, then. So I guess there are no more doubts since no one else is asking in the chat. So I guess we'll be closing the session, guys. So just wrapping up, once again, thanks for joining the session, guys. Hopefully, I'll see you guys next week also, the same time under 6 to 8 p.m. I hope you enjoyed the you enjoyed the questions today. And yeah, I'll be uploading the today's video and these notes, so you can look at these later also. So yeah, I guess you guys can leave the session. Once again, thanks for joining, and I'll be stopping the recording and closing the meeting. Okay, guys. Bye bye. Thanks for attending.